In this video, we're going to talk about function M files. Function M files allow you to write your own user-defined functions that work similarly to MATLAB's built-in functions that we got introduced to last week. Our objectives in this video are to understand the difference between a function M file and a script M file. Remember, a script M file, this was what we covered last week. We want to understand the concept of a local variable and why this is a useful way of doing things. We want to understand how values pass between the main workspace and function workspaces. That'll make more sense as we get into the video a little deeper. We want to learn how to write user-defined functions that accept multiple input arguments and return multiple outputs. And also we want to use anonymous functions to create user-defined functions for one-line mathematical expressions. So what is a function M file? A function M file, the main difference between a function M file and a script M file when you open it up in the MATLAB editor is the first command. What makes an M file a function M file is having as its first line the function command. And the syntax of the function command is the word function, and then an output variable list, then the function name, and then in parentheses an input variable list. An important thing here, this output variable list is in square brackets, and those square brackets actually aren't necessary if you only have one output variable, but it's fine to leave them there if you have one output variable. One note here, the function name must be exactly the same as the file name. That's how MATLAB knows how to use that function when you're using it in a MATLAB session. So here's a simple function M file as an example. This is a function M file called deg2rad.m, and here's what that M file looks like. It has the function command with the output variable and one input variable, and the function name deg2rad is exactly the same as the file name deg2rad. And as you might guess, and you can see from reading the help comments here, this is a function that converts an angle in degrees into an angle in radians. And you can see what basically happens is we will input the angle in degrees, do our calculation, and this can be several lines. There's no limit to how long a function can be. It can be several lines. In this case, it's one line. And then we will return the output through the function command. We'll talk more about how this works and how you would run this function. So here's some examples of how you can run this function. So first of all, we can type help deg2rad just like we would type help sign, for example, for a MATLAB function, and the help comments show up. Now, one thing that's important in the help comments for a function M file that's a little bit different from a script M file is we really want to include this information on how we call the function. What are the input variables and what are the output variables? And it'll become more clear as to why that's important as we talk about multiple input and output function here in a minute. So we can use it just like a built-in function. So we can type, for example, deg2rad30. There's our input. And the function works to take 30, which it would be in degrees. The function would interpret that in degrees, convert it to radians, and spit out an answer. Now in this case, we don't have an output variable to assign the answer to, so MATLAB creates the generic answer variable since we haven't assigned the output. We can also use this by assigning the output variable, again, just like a MATLAB built-in function. So in this second example, we've defined a variable alpha equal to 45, and then sent that variable. We're going to send that variable as an input to deg2rad. Deg2rad is going to do the calculation and return the output, and we've now assigned the output to alpha_rad. So that creates a variable in our workspace called alpha_rad and assigns it this value 0.7854. So let's look a little bit more at what that function command is actually doing. So what happens when we have a function command at the top of a script M file is that the function sets up a temporary workspace that only exists while the function is running. So all of the variables inside the function are local to that function. And so you call the function, say from the command window or from another script. The first thing the function does is sets up that workspace and then passes values from the function call into the workspace based on their position in the input and output lists. The variables inside the function are local, which means they exist. Sorry about the spelling there. Those variables exist only in the function workspace. Okay, so let's look a little bit more about what this means to pass by position. So here's our function call that we looked at before, alpha equals 45 and alpha_rad equals deg2rad of alpha. So as soon as we write this command, what MATLAB's going to do is it's going to go to our function M file. It's going to look for a function called deg2rad. When it finds deg2rad, it takes the variable alpha, which is the only alpha and the only variable in the input list, and passes that in to the variable angle in degrees. Then inside the function, so it's as if we had a statement in this function that said angle in degrees equals alpha. But we can't because alpha doesn't exist in the function workspace. So here's alpha down here. This is the workspace in the called the base workspace or in the command window. Alpha doesn't exist in the function workspace, and we'll see how we can look into the function workspace in a minute. Alpha doesn't exist there, but its value is passed to the variable angle in degrees. Then we use that variable angle in degrees here to do this calculation and convert it to radians. And then once we've calculated angle in radians, we take the variables from the output list. The function takes the variables from the output list and now passes those back through the assignment to alpha_rad. And so we get our result, alpha_rad equals 0.7854. So here's our main workspace, or our base workspace as a result of this function call. We've defined alpha and we've calculated alpha_rad using the function. Notice that there's no variable in the workspace called angle in radians, or there's no variable called angle in degrees either. These variables do not exist in the base workspace. They only exist in that function specific workspace that the function statement here creates when we call that function deg2rad. That's what we mean by a local variable. These are local variables. Angle in radians and angle in degrees are local to the function workspace. So it might seem like this is confusing, and for some students this can take a while to get figured out, but we want to keep the big picture in mind as we get more and more into MATLAB programming, and that's that local variables are actually a really good thing. This concept is a really good thing because what it does is it makes it so we can write functions to do specific calculations without worrying about variable naming conflicts with other functions, scripts, or the session in the command window. In other words, if we want to use a variable called radius inside a function, we don't have to worry about overriding the value of another variable called radius that we're using in the command window. This allows what's called modular programming. So as you get into more sophisticated and complicated MATLAB problems, the best approach is to take that problem and break it down into several smaller problems, and then you can write functions for each of those smaller problems, and then have a main script that solves the overall problem. And we'll see an example of that in the next video. So let's look at a function with multiple inputs and outputs. Now this should look pretty similar. This is similar to our example from the first week where we use sine law and cosine law to calculate sides of a triangle. So what's going on here? Here we have multiple inputs. There's 3 inputs, which we've called A, B, and gamma, and there's 4 outputs. So these are the values that are going to pass back and forth between the workspace that's specific to the function called triangle laws and the base workspace in the command window. You'll notice here I've made these help comments are much longer in this example. All of these will show up as the help comments. And the reason for that is we want to include everything in the help comments that we need in order to use the function. And since the variables pass by position, we need to know what do each of the variables in the input and output lists mean if we type help in the command window to get information on this function. So our help comments, and this is a more general list of what the help comments for a function should look like. We will have an example function call. We have a general purpose of the function is the next sentence or two explaining the general purpose of the function. And then we have a list of the inputs and outputs. So here we list all the inputs and outputs so that we know what all those variables mean. And if the more descriptive your variable names are, the better, and that means less need for comments. But in this case, we're kind of using the standard variables for triangles, A, B, C, and alpha, beta, and gamma for the angles. So we just want to make sure everything's clear. The next thing we'll do is do our calculations. So here you see we have several calculations. You'll notice we have an intermediate variable h. H is local only to the function, and it's not in the I/O lists. And that's fine. H is an intermediate variable in the calculation. We have no need to pass it back to any other workspace. One important thing on the calculations here is we want to suppress all output. And the reason that we want to suppress all output from a function is because it can be confusing when that output shows up in the command window, but you're not actually making changes to the command window workspace. Because the only way you make changes to the command window workspace are by what you pass through these outputs. That's called the base workspace. So let's move over to MATLAB and work with this function a little bit and get a little bit better sense of what's happening here. Okay, now I'm in MATLAB and I've got the command window here, and I'm just about to execute a command to call the function we just looked at called triangle laws. And I will send it the inputs of 2, square root of 3, and 30. In other words, two sides of length 2 and square root 3 with an included angle of 30 degrees. Should be a familiar triangle to most of you. The outputs will be assigned to 4 variables, S3, ang2, ang3, and area. So what I'm going to do is put a breakpoint in the function, and so that we can execute this line by line and see what happens. So before I call it, let's look down here. I've also have the workspace window displayed. You'll see right now it's cleared. There's no variables in the base workspace, which is the workspace that's associated with what's going on in the command window, and any script M files that I'm running out of the command window. Okay, so we'll run this, and when we run, we see that we're immediately at the first command after the function command, which is already executed in the function triangleLaws.m. So if we go back and look at that function command, we'll see what happens. So the function command again set up our function workspace for triangle laws, and we can see now we have in the workspace window we have a stack. We have 2 workspaces, one called triangle laws associated with this function, and one called base, which is associated with the command window. So what happened here is those inputs 2, square root of 3, and 30 went to A, B, and gamma respectively. And the way that they knew which variable to go to was simply by position. For example, square root of 3 was second in the input list. So here was our function call. Square root of 3 is second in the input list. So square root of 3 went to the variable B, which is second in the input list in the function call here. And we can see there it is in the workspace. 1.732 is the square root of 3. Okay, so let's go down here and execute this function. We'll execute it one line at a time by stepping through. And as we do that, if you look down in the workspace window, we're looking again at the triangle laws workspace. We can see that these variables are being created as we do these calculations. H, area, and then the next step will be to leave the function. So we've done all the calculations in the function. The green arrow pointing down tells us that the next step would be to leave that function. So before we do that, let's go look in the workspace again. So we've got all these variables we've created in the workspace. The base workspace is still empty. We haven't done anything in the base workspace. So what's happened is we have called triangle laws. We've sent it these 3 values. It's done all its calculations, and the next thing that's going to happen is this assignment. Remember that equal sign is an assignment, and it's going to assign the outputs based on position to the variables S3, ang2, ang3, and area. So let's go back to the editor, and we will step one more time. And there we are. Now we're looking at the base workspace, and we see those 4 values have been passed to the variables by position in the base workspace. So one thing that's really important here is when we're using a function with multiple outputs, we want to give it multiple output variables to assign those outputs to. So if we just, for example, had one variable, call it S3, or let's say we just wanted to calculate the angle, so let's just call this ang2. Let's see what happens if we try and do that with just one variable. So I'll hit enter. Let me go turn off the breakpoint first that's in the function. Okay, so I'll hit enter. And we see we just have ang2, and what we've done is we have reassigned the value of ang2. If you look down in the workspace, it's now saying ang2 is equal to 1. We know that's not right. And all it's done is taken the first value from the output, which again was the side length C, and assigned that to the variable we gave it. In the most extreme example, we could have no variables. Remember, we can call a function in MATLAB and not assign the output to any variable. So if we do that, then we just get the generic answer variable from MATLAB. So both of these are going to cause confusion, and it's not going to be clear exactly what we're doing and how we're working with variables in the workspace. And remember, that's what's most important, is what are we doing to the variables in our workspace. So the moral of the story here is when we are calling a function with multiple outputs, and some MATLAB built-in functions can have multiple outputs as well. When we call a function with multiple outputs, we want to make sure that in that function call we give it enough different variables here, so in this case 4 different variables, to assign those outputs to. And then when we do that, we'll get our values back correct again in the workspace. And let's return to the rest of the video. So a couple more things to talk about in this video. One, again, I want to emphasize this important note. When we're using a function with multiple outputs, you must provide multiple variables for it to assign the outputs to. If you assign the output to only one variable, only the first output will be brought into the main workspace. And that's what we saw here. Here's triangle laws, and then we get just the first variable, s, assigned a value. In this case, another example, here's 3 values. Remember that triangle laws has 4 outputs. But let's say I just wanted to use triangle laws to find the other side length and the angles of the triangle, and I don't care about the area. That's okay. So sometimes we might, by choice, do this because we only want the first 3 outputs. Okay, so the important thing here is to just be clear on what you're doing so you know which variables are getting assignments in that base workspace. Let's move on to a slightly different topic, and that's the topic of anonymous functions. Anonymous functions, so we started out with a simple function with 1 output and 1 input. Then we talked about a more complicated function with multiple inputs and multiple outputs. Anonymous functions are going the other way. Anonymous functions work to define simple one-line functions. And this can be useful, for example, to define a mathematical function that you're using repeatedly. So the syntax for an anonymous function is to define, here's your function name, and this just happens in the command window or in a script or in another function. We define the function name. Using the @ symbol, we define a variable list. This is your input. These are your inputs. You can have more than 1 input, okay? And then here's just the expression that we're calculating. Okay? So this actually becomes a function in the current workspace, and then we can use it just like any other function to do calculations. The key here is that this anonymous function, what's different from what we've talked about so far, is the anonymous function is only available in the same workspace as it was created in. So this isn't creating a separate workspace. We're just creating a function that works within the current workspace. You can pass the function as an input to another function, but passing functions to functions, this is for later. We won't even talk about that in this course. We do that in Engineering 240, but we'll talk about it then. So just want to recap some guidelines for writing functions. 1, make sure the function command is the first command in the function M file. 2, we want to make sure that the file name is the exact same as the function name. 3, we want to remember that values pass by position in and out of the function, and that's defined by the input and output lists in the function command. 4, we want to remember to suppress all output in a function M file, and This avoids confusion. If we have output in the function M file, you'll have variables that don't exist in the base workspace that do show up in the command window output. And we'll see an example of that in the next video. And lastly, make sure you write your help comments that include all of the information necessary to use the function.